Hello everyone, welcome back to Deviations. Now today's video is going to seem like quite the doozy because we are going to be talking about the reduction formulas. Now I did say we were going to be moving on to trigonometry, and well, we are. We're going to be doing quite a lot of trigonometry, but this in fact is still some integration by parts. All of these formulas are derived from integration by parts, and we will be looking at a ton of formulas today, and we'll be doing an example. Now, if you find this amount of formulas overwhelming and you are a high school student, fear not, because these formulas are not tested on the AP AB or BC exams. However, college students in Calc 2, sorry, I'm not sure. Probably they will be on this if they are in the book we are using. Okay, so let's have a look at some of these trigonometric reduction formulas. Now, these are going to be helpful when we have an integral of a trig function, and let's just write a trig in there. A trig function that's raised to a power n of x dx. Now, we have no idea how to deal with this. We're going to be looking at this in some other ways using some trig identities now, but we're going to look at this through an integration by parts lens first. But don't worry, we're only going to be doing one video on this. So let's talk about reduction formulas. So here they are. We're going to have 6 of them, one for each of the trig functions. Now, it should be noted that we can use this for the exponential function. This is really just a formula for like the tic-tac-toe method, how we formulate our integration by parts, but you should pick up on it by the second or third formula. Okay, so this is the first guy. Now, do not be worried. So we have here that the integral of sine to the n of x dx is equal to negative 1 over n sine to the n minus 1 of x cosine of x plus n minus 1 over n integral sine to the n minus 2 of x dx. Okay, now what do we see here? Well, this looks like something that we'd find in an integration by parts, right? Obviously, we're picking sine. It looks like to reduce, we have an n minus 1. So this looks like our first term, and then we have a constant here. Then we have another constant here. And these constants seem to be reducing progressively. And then we also have integrands that are reducing progressively. See, we go from sine to the n to sine to the n minus 2. So pay attention to that. That's going to be important. And so this, like, this sine to the n of x could be like sine to the 4th of x. And we'll do sine to the 4th of x as an example in the next slide. Okay, so now let's look at some of the other formulas. So we say if we have the integral of cosine to the n of x dx, that's equal to 1 over n times the cosine to the n minus 1 of x times the sine of x plus n minus 1 over n integral of cosine to the n minus 2 of x dx. Same sort of thing here, except we no longer have this minus sign. And of course, that's because when we do the integration, sine goes to a minus, cosine, of course, does not. Okay, so now we've also got the tangent. So if I want to take the integral of the tangent of x to the nth power, it's going to be 1 over n minus 1 times the tangent to the n minus 1 of x minus the integral of the tangent to the n minus 2 of x. Again, we're seeing very similar things here to what we've been seeing in the past. Okay, so let's take a peek at the cosecant integral. So for the cosecant, we have cosecant to the n of x dx is equal to negative 1 over n minus 1 of cosecant n minus 2 of x times the cotangent of x, and then that's plus n minus 2 over n minus 1 integral of cosecant to the n minus 2 of x dx. We had to do a lot of formula writing, so we didn't get that one right. So we have a lot more of these. Let's take a peek. So we've got the secant too. So the secant says that if I want to take the integral of the secant to the n of x dx, then that's going to be equal to 1 over n minus 1 secant to the n minus 2 of x, tangent of x, plus n minus 2 over n minus 1, integral of secant to the n minus 2 dx. Of course, this should be pretty trivial now. We're seeing a pattern here. And then we've also got, finally, got the cotangent. Sorry, that should not be cosine. Got cotangent. the integral of the cotangent to the n of x dx is equal to negative 1 over n minus 1 cotangent to the n minus 1 of x minus the integral of the cotangent to the n minus 2 of x dx. Okay, so now we've got some formulas. These guys here, probably not going to be important. Not really important. These guys here might be helpful, but given the trigonometric integration techniques that we're going to be covering in the next video, it probably shouldn't be terribly important that we cover those ones, just because we are going to be looking at them through a similar lens fairly soon. So let's take a peek at an example. Let's say I want to take the integral of sine to the fourth of x dx. Okay, so how do I do this, right? We need to look at our little formula. So we have, right, we have sine to the n of x. If I'm integrating that, dx, we are going to get negative 1 over n sine to the n minus 1 cosine of x, x there, and then we add, I'm going to put that down here, n minus 1 over n integral of sine to the n minus 2 of x dx. Okay, so now what we can do is we can just plug this in. Our n in this case is 4. So what's important is that we make sure that we remember some important trig identities. So we can remember that the sine squared, so sine squared is equal to 1 minus the cosine of 2x. That's going to make our job a little bit easier, so we don't need to go through this whole reduction mess again, because this is kind of a mess, to be honest. So let's start. So we're going to plug it in. The integral of sine to the fourth of x dx is equal to negative 1/4. Then we do a reduction, sine to the third of x cosine of x, plus 3/4 times the integral of sine squared x dx. Now we can plug in this, we have the x minus 1/2 cos 2x. We can plug that into the formula, plug that in there, and then we are going to get negative 1/4 sine to the cubed of x cosine of x plus 3/4 integral 1/2 times oh sorry, this isn't an x here. We've got a 1. Just looking at an integrated version. My apologies. So we have 1/2 times 1 minus cosine of 2x dx. Okay, so now this is easy integration. Sorry, this is going to go to x, and then we know how to do this when we have the constant in the argument there.